Two civilizations, both intelligent, both curious, both spending centuries building the technology to reach out across the dark, both pointing their most powerful transmitters at each other and sending everything they know, their science, their mathematics, their history, their existence, outward at the speed of light. And both of them dead and gone before the first signal from the other one arrives. This is not a thought experiment about bad luck. This is not a pessimistic edge case. This is the default outcome when you apply the actual speed of light to the actual size of the universe. The speed of light is not fast enough, not even close. And I want to show you exactly why, because the numbers tell a story that almost nobody has been told honestly. Let me begin with something that sounds like praise, but is actually the setup for a problem. The speed of light is 186,000 miles per second. In 1 second, light covers a distance that would take you to the moon and back almost halfway. In 8 minutes, light crosses the 93 million miles between Earth and the Sunday. In just over 4 years, light reaches the nearest star. These numbers sound impressive because we're comparing them to human experience, to cars, to planes, to the fastest things we've ever built. Against those references, the speed of light seems infinite, practically unimaginable, something that makes distance irrelevant. But we are not comparing the speed of light to cars. We are comparing it to the universe. And when you make that comparison honestly, the speed of light transforms from something impressively fast into something almost tragically inadequate for the task the universe seems to require of it. Here is the comparison that matters. The observable universe is approximately 93 billion light-years in diameter. That means light moving at its maximum possible speed takes 93 billion years to cross it. The universe is only 13.8 billion years old. Light has not had time to cross the universe even once since the beginning of everything. The universe is not just large, it is so large that even the speed of light, given the entire current age of the universe, cannot bridge it. Now, let's talk about what that means for civilizations trying to connect. A civilization that wants to contact another civilization has one practical tool: electromagnetic signals. Radio waves, light pulses, laser beams, all of them travel at the speed of light. You point your transmitter at a target star, you fire your signal, and you wait. The signal travels at 186,000 miles per second. It is the fastest thing you can send, and that is the speed at which civilizations can, in theory, exchange information. But the exchange requires both sides to be alive and listening when the relevant signals arrive. And this is where the mathematics starts to work against hope. Consider two civilizations separated by 1,000 light-years. That is a short distance by galactic standards. Our galaxy is 100,000 light-years across. So these two civilizations are relatively close neighbors. Civilization A sends a signal to Civilization B. That signal takes 1,000 years to arrive. Civilization B receives it, formulates a reply, and sends it back. That reply takes another 1,000 years. So the minimum time for a single exchange of two messages, one question and one answer, is 2,000 years. 2,000 years ago, the Roman Empire was at its height. The calendar had not been standardized. Most of humanity was farming with wooden tools. 2,000 years is the entire span of the Common Era. That is how long a single conversational exchange takes between civilizations that are, by galactic standards, practically neighbors. And here is the brutal follow-up. A civilization has to be continuously active, continuously transmitting, and listening for the entire duration of that exchange. It has to survive, unchanged in purpose and direction, for 2,000 years just to complete one round trip of communication. Human civilization has existed for roughly 10,000 years, but continuous, technologically sophisticated civilization, the kind that could build and operate radio transmitters, has existed for barely 100 years. We have been in the communication game for a century. A 2,000-year conversation requires a continuous civilization 20 times older than our current technological era. And that's for a neighbor 1,000 light-years away. Most of the Milky Way is farther. The galactic center is 26,000 light-years from us. A civilization there and a civilization here would require 52,000 years for one conversational exchange. The entire span of human prehistory, from cave paintings to civilization, fits inside a single round-trip signal between opposite sides of our galaxy. Now stretch this to the scale of the observable universe. The nearest large galaxy beyond our own is Andromeda, 2.5 million light-years away. A signal from a civilization in Andromeda sent 5 million years ago might just now be reaching our corner of the Milky Way. 2.5 million years ago, our ancestors were Homo habilis, not yet fully human, using simple stone tools, with brains considerably smaller than ours. The civilization that sent that signal, if it still exists, has been waiting 2.5 million years for a reply. And if we sent one today, they'd wait another 2.5 million years to receive it. That is not a conversation. That is two people shouting into opposite walls of a room so large that the echo takes longer than the history of our species to return. Let me now introduce a concept that I think reframes this entire problem in the most important way. The concept is not widely discussed outside of cosmology, but it should be. It is called the Hubble sphere, or the Hubble volume. The universe is expanding. Every galaxy beyond our local group is moving away from us, not because it is flying through space, but because space itself is stretching. The farther away a galaxy is, the faster space between us, and it expands. At a certain distance, called the Hubble radius, space between us and a distant galaxy is expanding at exactly the speed of light. Galaxies beyond that distance are receding from us at faster than the speed of light. This means that a signal we send today toward a galaxy beyond the Hubble radius will never reach it. We fire our transmitter at maximum power. The signal travels at the speed of light, but the space between us and the target is stretching faster than the signal can cross it. The target is always moving away faster than our signal moves toward it. The Hubble radius today is approximately 14.4 billion light-years. Everything beyond that distance is, right now, moving away from us faster than light can chase it. Any civilization beyond that boundary is completely and permanently unreachable by any signal we could send. We cannot contact them. They cannot contact us. The physics does not allow it. And here is what that means in terms of how much of the universe is actually accessible to communication. The observable universe, the sphere of space from which light has had time to reach us since the Big Bang, has a radius of about 46 billion light-years. That seems like a large communication zone. But the Hubble sphere, the zone within which signals can actually reach their destinations, is only about 14.4 billion light-years. Everything outside that zone is permanently beyond reach. The majority of the observable universe, the majority of those 2 trillion galaxies, is already beyond the zone of possible communication. And it gets worse over time. The universe's expansion is accelerating. The Hubble sphere is shrinking relative to the observable universe. Every year, more galaxies cross beyond the reachable boundary. Every year, the universe becomes more fragmented. The window of possible communication between distant civilizations is not holding steady. It is closing, slowly but permanently. This is the most important fact about the speed of light that almost nobody talks about. The speed of light is not a fixed communication radius. In an expanding universe, it sets a shrinking communication zone. The universe is actively, continuously reducing the number of civilizations that any given civilization can ever hope to contact. Now let's talk about our own communication zone, the specific bubble around Earth within which contact is theoretically possible. Our oldest radio transmissions, the first signals we broadcast that could carry evidence of our existence, are about 100 years old. In that time, those signals have traveled 100 light-years from Earth, expanding outward as a sphere. Within that 100 light-year radius around our Sun, the Milky Way contains a few thousand stars. Most of those stars, based on what we know about stellar populations and planet formation, have planets. Some fraction of those planets might have conditions suitable for life. Some much smaller fraction might have life. And some tiny fraction of those might have intelligent, technologically sophisticated life. The estimates vary enormously, But even the most optimistic projections suggest that within 100 light-years of Earth, we should not expect many, if any, civilizations comparable to ours. The density of intelligence in any given region of space is simply too low. Our signals, after 100 years of travel, may well have swept past nothing more complex than microbes, if that. And the signals traveling outward from Earth right now are not targeted. They are spherically symmetric, spreading in all directions, diluting in strength as they go. The inverse square law means that signal strength drops with the square of distance. A signal 100 light-years away is 10,000 times weaker than it was at 1 light-year. At 100 light-years, our strongest deliberate transmissions, the Arecibo message, the Voyager Golden Record data, would be indistinguishably faint against the background noise of the universe for any reasonably primitive receiving technology. For a civilization to detect our transmissions at 100 light-years, they would need extraordinarily sensitive instruments, and they would need to be looking exactly at us at exactly the right time. The probability of all of those conditions being simultaneously met is extremely small. So even within our modest 100 light-year communication bubble, contact requires extraordinary good fortune on both sides simultaneously. Now I want to think about this from the other direction. Not what signals we're sending, but what signals might be coming toward us that we haven't detected. SETI, the Search for Extraterrestrial Intelligence, has been operating for about 65 years. In that time, researchers have surveyed a fraction of the sky in a limited range of frequencies using increasingly sensitive equipment. The most famous result is the WOW signal of 1977, a 7-2-second burst of radio waves with characteristics consistent with what a deliberate extraterrestrial transmission might look like. It came from the direction of the constellation Sagittarius and was never detected again. Whether the WOW signal was artificial or natural in origin remains unknown, but it illustrates the challenge. Even a single brief, strong signal from a nearby direction is extraordinarily difficult to confirm, characterize, and respond to. And we've been listening for 65 years. Against the total age of the universe, 65 years is not an afternoon. It's a fraction of a second. We have not listened long enough, broadly enough, or sensitively enough to draw any firm conclusions from the absence of a confirmed signal. But the mathematics of the speed of light suggests that even if we listened perfectly and indefinitely, the number of civilizations we could ever realistically exchange meaningful communication with is vanishingly small. Not because civilizations don't exist, but because the speed of light, applied to the distances involved, produces communication delays so extreme that meaningful exchange, the kind where both sides ask questions and receive answers within any single civilization's lifespan, is almost impossible except between civilizations that are extraordinarily close in space. How close? Let me put a number on it. For a back-and-forth exchange to happen within the lifespan of a single civilization, let's say a civilization that maintains technological continuity for 10,000 years, the two civilizations would need to be within 5,000 light-years of each other. At 5,000 light-years separation, a round-trip signal takes 10,000 years. That just barely fits within our hypothetical civilization's lifespan. Within 5,000 light-years of Earth, the Milky Way contains roughly 50 million stars. That sounds like a lot. But if civilizations are rare, if only 1 in a million star systems develops a technologically sophisticated civilization, then there are roughly 50 civilizations within communication range. And for exchange to happen, both civilizations need to be alive at the same time, both need to be broadcasting, and both need to be listening in the right direction at the right frequency. The probability of all of those conditions being met simultaneously across any given pair of civilizations is very small. Not impossible, but small enough that it is entirely consistent with the observed silence of the universe so far. And here is the darkest version of this calculation. If civilizations typically last only a few thousand years before collapsing, destroying themselves, or going silent, then the window of overlap between any two civilizations within communication range might be measured in centuries or decades rather than thousands of years. Two civilizations might exist within 5,000 light years of each other, but their windows of active transmission might be separated by millions of years. They never overlap. Neither ever knows the other existed. This is what I mean when I say the speed of light is so limited that civilizations may never meet, not just in the physical sense of visiting each other, in the communication sense, in the knowing about each other sense. The universe's geometry and the universe's speed limit, working together, create a structure where intelligence is deeply isolated by default, where meeting in any meaningful sense requires an improbable alignment of proximity, timing, and persistence that the numbers suggest will almost never happen. I want to say something careful here, because I don't want to overstate what we know. We have not proven that no civilization has ever contacted another. We have not proven that contact is impossible. We have not searched enough of the sky for enough time with enough sensitivity to draw sweeping conclusions. The absence of a confirmed signal after 65 years of searching means something, but it does not mean everything. What the mathematics does justify is this: contact between civilizations, if it happens, requires overcoming obstacles that are not engineering problems. They are structure of the universe problems. They are built into the relationship between the speed of light, the size of space, and the expansion of the universe. No improvement in technology changes the fundamental calculation. You cannot build a faster radio wave. You cannot make light speed faster. You cannot make the universe smaller. The numbers are what they are. A civilization that fully understands its situation knows this. It knows that the probability of receiving a signal from another civilization, a signal that carries enough information to be recognizable from a source close enough that a reply is possible within any conceivable time frame, is very low. Not zero, but very low. And the probability decreases over time as the universe expands and more potential partners recede beyond the Hubble horizon. What does an intelligent civilization do with that knowledge? I think it does what any careful, honest mind does when it encounters a hard constraint. It adjusts its expectations to match reality rather than hope. It focuses on what is actually achievable, detecting signals from anywhere, regardless of whether a reply is possible, learning from them, understanding that even a one-way message, even an unintelligible signal that merely confirms another mind existed somewhere, changes the entire human picture of our place in the cosmos. The goal of contact doesn't have to be conversation. It can be witness. Knowing that something else was out there, even if it has been dead for 1,000,000 years by the time its signal reaches us, is not nothing. It is perhaps the most important fact our species could learn: that the universe produced intelligence more than once, that we are not a statistical accident in an otherwise empty cosmos. That the conditions for mind are general enough to have happened twice. That confirmation, even one way, even ancient, even incomplete, would be worth every radio dish we've ever built and every hour we've ever spent listening. But the speed of light means we should hold that hope with open hands, not clenching it, not building our picture of the universe around the assumption that contact will happen, but remaining genuinely open, genuinely attentive, genuinely curious, while accepting that the universe may have arranged things in a way that makes meeting profoundly, structurally, permanently rare. There is one more thing I want to add because I think it reframes the entire subject in a way that matters. We talk about civilizations meeting as if meeting is the point, as if contact, communication, exchange, as if these are the goals the universe should be cooperating with. But the universe doesn't have goals. It has structure. And its structure, the speed of light, the expansion of space, the distances between stars, produces isolation as a natural outcome of the way things are arranged. That isolation is not a failure. It is not a bug. It is not evidence that the universe is cruel or indifferent to curiosity. It is simply what happens when you distribute matter across a volume so large and impose a speed limit so absolute that most of what exists can never interact with most of the rest of what exists. The universe is full of things that will never know about each other. Stars that will form and die in complete isolation from any observer. Planets that will develop complex chemistry, and perhaps life without any other civilization ever knowing they existed. And civilizations, if they exist in the numbers, we suspect spending their entire histories looking outward at a universe that is mostly too far away to answer. The speed of light sets the size of each civilization's universe, not the physical universe, the knowable universe, the universe that can, in any time frame, send information and receive it. And for most civilizations, most of the time, that knowable universe is a sphere of a few thousand light years, a tiny bubble inside a galaxy that is a tiny speck inside a cosmos of unimaginable scale. We live inside our bubble. We look out past its edges, and we see light from places we can never reach and never hear from. And we call that the universe. But really, it is just the neighborhood we happen to be able to see. The rest of the universe, the part beyond the reach of our signals, beyond the range of any reply that could arrive before our civilization ends, is not part of our story. It never was. It never will be. The speed of light makes sure of that. And once you sit with that, once you really let the numbers land, it becomes the most profound statement in all of physics, that the universe may be full of minds, and those minds may all be alone, not because the universe is empty, but because light isn't fast enough to connect them.